Assalamualaikum students. This video lecture is for my class, subject physics, chapter number 8, and today our topic is volume thermal expansion. Students, in last video we discussed linear thermal expansion, in which we discussed change in length with the change in temperature. But today we will discuss change in volume with the change in temperature. So some of the symbols I will tell you. This V naught shows initial volume, V shows final volume, and delta V change in volume. And same is the with temperature, initial temperature, final temperature, change in temperature, and beta shows temperature coefficient of volume expansion. Students, in this diagram we have a solid. Its volume is V naught at temperature T naught, but with the change in temperature, or you can say with the increase in temperature, its temperature becomes T and volume becomes V. Change in anything, in any quantity, is the final amount minus initial amount. So if we want to know the change in volume, so that is equal to delta V. Change in volume is equal to final volume minus initial volume. Same, change in temperature, final temperature minus initial temperature. Students, we know that from here we can see that change in volume is directly proportional to initial volume and change in temperature. If initial volume is more, then final volume is more. Change in volume is more. If initial is less, then change in volume is less. So if change in temperature is more, then change in volume is more. If change in temperature is less, then change in volume is also less. It means that change in volume is directly proportional to initial volume and change in temperature. When we remove the sign of proportionality here, equal sign and a constant, delta V is equal to beta V naught delta T. This beta is thermal coefficient of volume expansion that we will discuss later. So we will put the value of delta V from here, V minus V naught. So V naught, its value is negative here. On the other side it becomes plus. So V naught plus beta V naught delta T. From here we will take V naught as common. So V naught into 1 plus beta delta T. So from this equation we can derive the value of, we can eliminate beta, which is temperature coefficient of volume expansion, which is equal to delta V over V naught into delta T. So from this formula we can define the value of temperature coefficient of volume expansion, which is beta. It is fractional change in volume per Kelvin change in temperature. It means that with the change in temperature, how much change in the volume, that is called beta, temperature coefficient of volume expansion. Its unit is per Kelvin. Why? Because volume and volume both cancel out each other. Here in denominator here is temperature, so temperature unit is Kelvin, so it becomes per Kelvin. Its unit is per Kelvin, and its value is constant for a specific solid, and it's different for different solids. For example, its value is constant for copper, which is equal to 5.1 10 raised per minus 5 per Kelvin, and for steel 3.6 10 raised per minus 5 per Kelvin. Its value is constant for copper, this one constant for steel, this one, but copper and steel, their values are different from each other. Thank you. Allah.